you, Zafir. He's late.
So let's begin things off by selecting the video we want to analyze using the tracker. Then I select create point and point mask. Here you can see me zooming into the egg and adjusting the slider to the point just before my teammate drops the egg. And at this point, I right click on the slider and I select set start point for cursor. And here you can see me zooming in onto the landing pad and adjusting the cursor to just when the egg hits the pad. And same thing, I'm right clicking and selecting end frame to slider. Okay. Then at this point, I am shift clicking onto the center of the egg. Every time I shift click, a little red diamond appears at where I click, which is ideally in the center of the egg. And I repeat this until the egg reaches the landing pad. Now as I click on each frame, you can see that the graph on the right is slowly pinpointing the values that I'm providing it with by clicking on the egg. It is evaluating the displacement, velocity, and acceleration of the egg. Now at some points, you can see that the graph is not a very smooth curve. This is because of the accuracy and the quality of the camera. And there goes my last marker. Now at this point, I move on to the graph, and to the left of the y-axis there is a little button that I can press to edit the variable that I want to find. The first one being displacement, the second one being velocity, and the third one being acceleration. And I right click on the graph on each graph to take a snapshot of each. And here you can see all three of my graphs together. Thank you very much.
Before I start my discussion, I would like to just say that we took downwards as positive for our entire experiment on the tennis ball. Yeah, okay. So for the displacement time graph that we saw, it generally looked like an inverted version of the actual path of the tennis ball, probably because we took downwards as positive. From what we can see, it's that the upward force of after every downward force is usually 2/3 of the previous downward force, probably due to the force being dissipated into the ground. This continued until it came to a stop. Next, from the velocity time graph, we can see a nice pattern of zigzags. This is because during the upward, the velocity is constantly increasing until it touches the ground, where it will bounce back and change in its direction. This bounce back can be seen from the sharp drop in from a positive velocity to a negative velocity. As we have said earlier, the downward force is the positive reading. Finally, for the acceleration time graph, we can see that generally there's a constant acceleration that can be seen, other than the fact that there's a sharp drop every time the tennis ball touches the ground. This constant acceleration is obviously, from what I've learned, is gravity, but these slight variations are mainly due to probably the winds and also highly due to air resistance. The sharp drops are because as the tennis ball touches the ground, it has reached a state of no motion at all, thus having zero acceleration at all.